Hello and welcome to Unit 5, Lesson 7. Today we're going to go ahead and look at reduced row echelon form. Your learning target for today is that you will solve a system of equations using reduced row echelon form. And then I'm also going to show you how to use reduced row echelon form on your calculator to solve a system of equations. Okay. So far we've solved system of equations using algebra and inverse matrices. So this is just another technique to go ahead and add to our list of tools in order to solve a system of equations. So elementary row operations, okay? So what we're gonna try and do is get the identity matrix in a reduced row echelon form. So just to remind you, in a 2 by 2, our identity matrix is 1, 0, 0, 1. Okay, so this is going to be our goal. And the way we can go ahead and do that is you can interchange two rows. You can multiply every element in a row by a non-zero constant. And you can add elements of one row to corresponding elements of another. Okay, so let's go ahead. Reduced row echelon form. So what is it? You're going to take a system of equation and make a matrice. And then it's going to be a 2 by 3 if it's a system of two equations. And then your goal is to change those elements to 1, 0, 0, 1, which is the identity. And if it's a 3 by 3, this is your goal to get the identity for a 3 by 3 matrix. Okay. If you do that, then your solutions will be the numbers that are listed here and here, or it's a 3 by 3 at the very end, okay, that last column. So here we're going to solve a system of equations using reduced row echelon form. So step 1 will be to write an expanded matrix. Okay, so what we do is we only go ahead and look at the coefficients and constants with our system. And we write a 2 by 3 matrix. Okay, so I will have -2, 3, 3, 2, 4, 7. This is my expanded matrix. Now my goal is to have the identity matrix left here. Okay. And I start with, and I always go in this order, is I always make this element be the number 1. Okay. Then I move on and I make this element 0, then to this element to make it 1, and lastly I make this one 0. So we go in this counterclockwise rotation, and we always start with this element right here. Okay, so our first goal is to make this be the number 1. Okay, we can only change one row at a time. So I'm only going to change one row. And I can add, I can interchange rows, I can multiply by a scalar. Those are kind of some of the techniques that I can use. Okay, so I'm starting with this one. So I know I'm only going to change row 1. So that means I'm going to keep row 2 exactly as is. So I'm just going to rewrite row 2. We would have 3, 2, 7. That is going to stay as is. Now, if I look at this, with these numbers here, is there any way to make the number 1? Well, if I take -2 plus 3 and add them together, I will get the number 1. So what I'm going to do is I'm going to take my row 1 plus my row 2 to get my new row 1. So remember, this is our row 1, and then this is row 2. So row 1 plus row 2, if I do this, I would have -2 plus 3, that gives me 1. Then I would have 3 plus 2 is 5, and 4 plus 7 is 11. First goal met. Now I move on to my next goal, okay? I need to make this number be 0. Well, the way I can make things be 0, and a lot of times this is how you handle it, is by adding or subtracting the opposite value of it. So currently it's a +3. So if I were to add a -3 to it, then I would go ahead and I would get 0. So the next time I go, I know I'm only changing row 2. So I'm going to rewrite row 1 because it is staying the same. Now what I will do is, in order to get a 0 here, I'm going to take this times a -3. If I take it times -3 and I add it to this row, I would get the number 0. So I'm going to do a little side work off to the side here. So this is work side note. Let's call it a side note. I'm going to take my row 1 times -3. Okay, taking my row 1 times negative 3. So I will have negative 3, negative 15, and negative 33. And then my row 2 is staying the same. And then if I were to add these two together to get my new row 2, then I will have 0. So I took my row 1 times negative 3 and I added it to my row 2. And now I'm going to get my new row 2 right here. So when I add these two together, I get 0. I get negative 13. Negative 33 plus 7, I get negative 26. Okay, so there is that. Now I look at my next goal. Okay, I met my goal of getting a 0 here. Now I'm moving on to my next goal. I need to get a 1 here. Okay, a lot of times what you can do is, if you guys look at this whole row, what are they all divisible by? They're all evenly divisible by 13. And I want this to be the number 1. So I'm going to do is divide row 2 by negative 13. Or the same as dividing by negative 13 is multiplying by negative 1 over 13. So my next move is I'm taking my row 2 and I'm going to multiply it by negative 1 over 13 to get, remember row 2 is still the only one changing, so row 1 stays the same. If I take row 2 times negative 1 over 13, I get 0. Negative 1 over 13 times negative 13 is 1. And negative 1 over 13 times negative 26 is a positive 2. By that process, I have now made this a 1, so I've met goal 3. Lastly, we need to make this a 0. Anytime we're trying to get zeros, you guys, you're mostly going to take the other row and multiply it by the opposite sign of what you need to get rid of. So like right now, I need to get rid of this 5, so I'm going to multiply this by a negative 5. And then when I add the two together, I will get 0. Okay, so here is, I'm going to, row 2 staying the same. So I'm going to rewrite row 2 really quickly so I don't forget that. And now I'm going to take row 2 times negative 5. Okay, so I will have row 1 is going to stay the same, and then I'm going to add it to negative 5 times row 2. So it's going to do a little side note and do that work. And some of you are really good with adding and multiplying, so you don't have to do a little side note, but if it helps, please write it down. So row 1 staying the same, so I'm going to write row 1, 1, 5, 11. And now I'm going to take this row 2 times negative 5. So 0 times negative 5 is 0, negative 5, negative 10. And now I just have to add these together. So I get 1, 0, 1. Now have I reached my goal? My goal was to have 1, 0, 0, 1, my identity matrix. Yes, I have. And since I have reached my goal, I now know that I have my solutions here. These are my solutions. And this means my x value is 1 and my y value is 2. So my solution is 1, 2. So this is my reduced row echelon form, okay? And it helped me solve for x and y. It's a lot to take in, okay? So just maybe think it through a little bit. Lots of different tools and techniques we can use. So you just have to try and think like, how could I make this happen? Okay. Let's try another one. If you're feeling a little iffy, it's going to be okay. So let's give another one a try. Okay. Let's write this one down. So we start with our expanded matrix. So that's just writing down all the coefficients and then our constants. So I have 5, 2, negative 4, 3, negative 3, negative 15. I know my first goal is to make this the number 1. It's not as easy as the other one because these two numbers aren't just a distance of 1 apart. So I'm like, oh, what else could I do? Another thing that I would look for when I'm starting with one of these is anybody in an entire row divisible by the same number? Can I divide out a number? If I look at row 2, what is all of row 2 divisible by? It's divisible by 3. Okay. So what I'm going to do is I'm going to take that row 2 and divide it by 3. What's the same as dividing by 3? Multiplying by 1/3. So I'm going to do 1/3 of row 2 to start out. 5, 2, negative 4, and then 1/3. So 3 divided by 3 is 1, negative 3 divided by 3 is negative 1, and negative 15 divided by 3 is negative 5. This is nice. I now have a 1 in this spot. However, I need a 1 up top. Another tool that we can use, we didn't use it on the last one, is you can interchange rows. So I'm going to just take and switch the rows. Because couldn't I have easily had these two equations switched to begin with? Yeah, I could have. So I could have set it up that way. But I didn't because I want you guys to see that you can interchange rows. So I'm going to switch the rows. So I now have 1, -1, -5, 5, 2, -4. So now I have met goal 1. Goal 2 is to make this a 0. The way you guys' 0 happens is you take the opposite row and multiply it by that opposite sign. Okay, so this is a positive 5, so I'm going to take this one times -5, and then I'm going to add them together. So I'm going to take my row 1 times -5, and then I'm going to add it to row 2. So let's just remember who is staying the same this time, because we can only change one row at a time. Row 1 is staying the same. And now from here, I'm going to go ahead and do my little note off to the side. So I multiply all of row 1 by -5. So I got -5, 5, 25. And then row 2, 5, 2, -4. And then I go ahead and I add the 2. This gives me 0. This gives me 7. This gives me 21. Okay. Now I have met goal number 2. Goal number 3 is to make this the number 1. Okay. I'm telling you this happens a majority of the time. Okay. How did we go and make this a 1? We assessed this whole row. Are they all divisible by the same thing? They were divisible by -13. How about here? Is this one all divisible by the same number? Yes, they are all divisible by 7. So I'm going to take my row 2 times 1/7. So now I have 1, -1, -5. And then I would have 0 divided by 7 is 0. 7 divided by 7 is 1. And 21 divided by 7 is 3. Now I have met goal 3. Final goal, making this 0. Oh, that's super nice. I notice if I were to add my rows together right now, what would I get? I would get 0. So I'm going to take row 1 plus row 2. And remember, I can only change one row at a time. So the bottom row is staying the same. I'm not changing that one. So it's just these two. Now I'm going to add them. I got 1, 0, -2. And now have I reached my goal? 1, 0, 0, 1. Yes, I have. So my solution is what we got listed right here. So my solution is -2, comma, 3. So that is how you do reduced row echelon form by hand. Okay. I want you guys to be exposed to know how to do it by hand because there is an entire course in college, if you choose to take it, solely on matrices. Okay. It's called linear algebra. And you would need to do this by hand without your calculator. Okay. But this is the process you would need to take. I'm now going to show you how to do it on your graphing calculator. Okay. But it's good to know what process your calculator is going through as it does this for you. Okay. So example 1 and 2 is showing you by hand. And now I'm going to show you how to do it on your calculator, okay? So when you guys do this on your calculator, the work that I need you to show is I need you to give me your expanded matrix, okay? Your expanded matrix is the matrix that we started out with here. Then I'm going to ask for your reduced row echelon form matrix, which is what we ended with. And then finally your solution. So those are the 3 steps you need. And you will be able to use your calculator moving forward. So it's just good to know what you are doing, what your calculator is doing for you. Okay, so that's what the point of example 1 and 2 are. So expanded matrix, let's write it out. When we're solving a system of 2 equations, it's a 2 by 3. So we got to write a 2 by 3 expanded matrix. So we got 3, -1, 2, 1, and then 11 and 3. Now, list the RREF of the matrix. What that stands for is reduced row echelon form. And so we're going to get this off our calculator. Okay. So we're grabbing our graphing calculators or the app that we have for our graphing calculators. And I'm going to enter this matrix in. It's a 2 by 3. Okay, so I'm going to put in for matrix A, 2 by 3. So we're going to go second matrix over to edit. And I'm going to put in spot A, and it's a 2 by 3 matrix. Then our 2x3 matrix that we just listed off is 3, 2, 11. Then we got -1. Then we got 1. And then we got 3. Okay, there is our expanded matrix in our calculator. So we're going to go second quit. So when you put this in your calculator, first thing we do is enter the matrix. Make a note on here. So step 1, enter matrix. Then what we're going to do is we're going to go second matrix. And then we're going to go over to math. Okay, so let's do this on our calculator. So we're going to go second matrix, where we found our determinant, over to math. And then we need to find RREF. So I'm going to just scroll through this. I think it's like 11, but maybe I'm wrong. No, it's B. So B, RREF. So we select, not the negative, we hit enter. There we go, RREF. Okay, which is B. And then we do RREF. And then we go ahead and enter the matrix. Enter matrix A. Okay, so we go second matrix. Oh shoot, tried to grab the wrong calculator. We go second matrix, and I grab matrix A, and then I hit enter. And there is my reduced row echelon form matrix. 1, 0, 1, 0, 1, 4. Here is my goal. I have met it. And then this is your X and this is your Y. So for part B, list the reduced row echelon form matrix. It is, off our calculator, 1, 0, 0, 1. And I think the answer was 1, 4. So that'd be your RREF matrix. And then our solution, this is X and this is Y. So I have 1, 4. So our calculator makes it pretty easy for us. It's important though to still understand what's going on. But like I said, you will be able to use your calculator. Okay. We didn't do any of these by hand, but example 4, it's a 3x3 system of 3 equations. Okay. This is where it's a super nice to use RREF, is when you have a system of 3 equations. So step 1, list the expanded matrix. So that's taking all the coefficients off the front and putting them into a matrix. Okay, in this case, it's going to be a 3x4. So let's list our expanded. It's a 3x4. So all my X values, I'm just going to go down. I got 3, -2, 1. Getting my Y values, -2, 1, 4. My Z values, 5, 4, -7. And then lastly, my constants, 3, -2, 1. Now, to do this on our calculator, list the RREF matrix. We go to our calculator and we go to enter the matrix. So second matrix, gotta edit. I'm gonna put it in spot A again. If you want to put it in B, you can. And the size of our matrix this time is a 3x4. We enter in our expanded matrix from part A. So 3, -2, 5, 3, -2. Typically, if somebody has something wrong on a homework assignment, they just missed a number. So if you ever think you got the wrong answer, just go back and make sure you entered your matrix incorrectly. So we got 1, 4, -7, and 1. Okay. Remember, once you get your matrix entered, we always go second quit. Now I'm going to go grab RREF. So second matrix, over to math. I wonder if it's quicker to go all arrow up. Takes us to the bottom, maybe a little bit. There's RREF, enter. Grab our matrix. So with my 3x3, did I meet my goal? This part right here is my identity matrix. So yes, I did reach my goal. So this is my solutions, 1, 0, 0. So I need to write down my RREF matrix. So let's do that. And then we'll say what we got for our final answers. So B, we had 1, 0, 0. And then for our solution, we had 1, 0, 0. So this is my RREF matrix. This is our X. This is our y, and this is our z. So we will have 1, 0, 0. That is our solution for example 4, using reduced row echelon form on our calculator. Okay. Let's go ahead and move on to example 5. List the expanded matrix. Same thing, we're just grabbing those coefficients. So I got 3, 2, 7 for my x's. Then I got -2, -3, -3, 2, 4, 2, and then lastly my constants. 6, 0, -1. Now in order to get RREF, I go ahead and I put this matrix into my calculator. So the hardest part I think is really just typing it in. So second matrix, over to edit. Still a 3 by 4, and then I just need to put it into my calculator. So I got 3, -2, 2, 6, 2, -3, 4, 0. Last row, 7, -3, 2, -1. Okay. And then I go second quit, and then we just go ahead and grab our reduced row echelon form. So second matrix, over to math. I think it's quicker to go up, but you could also just arrow down until you get to B. So I hit enter, go and grab matrix A, because I saved it under matrix A, and hit enter. Now this one, did I reach my goal? Here's the identity matrix of a 3 by 3. Is this the identity matrix? It is not. Okay, so let's write down what we got for RREF, and then let's talk about what it means. Okay, so we had 1, 0. I'm going to put these as, yeah, that's fine. -0.4. 0, 1, negative, I want to say 1.6 is what it was. And then I had 0, 0, 0, and then I had 0, 0. All right, so when I look at this one is possible. There could be some solutions that give me x is 0 and y is 0. Same thing here. However, this is kind of my red flag. What this is saying is 0x plus 0y plus 0z equals the number 1. 0 plus 0 plus 0, does 0 equal 0? It does not. Okay, so that is not true. So what would our solution for this one be? This would be a no solution. Okay, so that would be your answer for that one. So you need to be careful. There are times where you won't actually get the identity matrix or our goal, and so that could be a possible option. Okay. The next one, we're going to go ahead and do this expanded matrix. We have 5, 2, 4, -6, -3, -3, 1, 1, -1, and then our constants 4, 1, 5. I'm going to go ahead and plug that into my calculator. I'm going to let you guys plug it in, give you a head start. Second matrix. I'm going to keep plugging it in for A, just easier because it's at the top, but you can definitely, like I said, plug it in for other ones. We got 5, -6, 1, 4, 2, -3, 1, and 1. And last row, 4, -3, -1, and 5. Okay. So we go second quit every time. Then we're going to go ahead and grab that matrix. So, sorry, not the matrix. We're going over to grab the reduced row echelon form. Hit enter. Grab the matrix. And this one, once again, I do not have my goal. So what does this one mean? Okay, let's write it down and talk about it. Actually means something different this time. What did we have? We had 1, 0, -1, 0, 1, negative 1, 0, 0, 0, and then I had 2, 1, 0. So in this case, when I check my last row, is it true from here that 0x plus 0y plus 0z, does that equal 0? That part is true. What this is saying, and I always have 1x plus 0y minus z equals 2, and I have y minus z equals 1. Okay, that's what I'm left with. So, is this true? It could possibly be true. However, we don't know. So if you have a situation like this, this would be not possible, or you could say that there's not enough information, okay, because it gave you that result. Okay, not possible, or not enough information. Okay, so you can't solve that one. But those are kind of your two options. No solution means you can't do it. This one, it's possible to do it, but we're maybe not enough information to actually solve it. Okay. And one last one, your turn. Let's go ahead and just give this one a try. So our expanded matrix would be 2, 1, 1, 5, 4, negative 3, 4, 3, negative 2, and then my constants 4, 1, and 5. Okay, let's go ahead and do the RREF on our calculator. You guys are probably getting really quick with this. So we're going second matrix, over to edit, still 3 by 4, and then I entered in. I got 2, 5, 4, and 4. Row 2, I have 1, 4, 3, 1, and row 3, 1, negative 3, negative 2, and lastly 5. And then we go second quit. We're doing RREF, reduced row echelon form, going over to math, all the way up. Grabbing matrix A. Hopefully you guys are getting the hang of the steps here. And I hit enter. Does this one work? Yes, it does. We got our goal here, and then these would be our solutions. Okay, so we need to write down the RREF matrix. So what do we get off the calculator? So we have 1, 0, 0, and then 3, negative 2, 2. Correct? I think that's what we got. Let's check. 3, negative 2, 2. Good. And then get the values of x, y, and z. There's my x, my y, and my z. So we always write them as ordered triples. So we got 3, negative 2, and 2. All right, so that will do it for lesson 5-7 on reduced row echelon form. You have a worksheet. If you have any questions, feel free to message me. Please reach out. Let me know what I can do to help. Otherwise, have a great day, and I will chat to you later.